Well, you know what? I think that she'll know where we are when we get in there, right?
Yeah, because my girls have softball. I've got to make dinner, so I'd rather be, and I've got two softball games and a concert tonight for my other daughter, so I really got to go too.
Yeah.
I like this.
And just for future reference, I can't push this time back ever. It is already pushed back for me so badly, so I can't ever push this time back.
Yeah.
Any further. Sorry.
It works, so I can be here on time from now on.
Okay. Okay, so group meeting.
Number 9, right? That's what we're on, right? Okay. Okay.
Stephanie, how'd you do on the quiz or the test?
Oh, the test ended up being a lot harder than I expected it to be. I didn't study what, on my note page, I didn't have very much information on there. That it was just, I put everything, I guess I'm used to tests that the review is the review.
Yeah.
Not a completely different test. So I didn't do very good, but that's okay.
That was my thing. I was like, if you're going to make a review, just make a review that has every single concept that will be on the exam.
Yeah.
So just use a little extra, but don't have things that aren't going to be there, or things, or leave out things that will be on there, because then you're just kind of, in a way, like screwing us over.
Right. Well, I just,
Are we
it was a little bit more shocking. Yeah.
Yeah.
A hypothesis test consists of 2 hypotheses, the null hypothesis and the alternative. Which one represents the status quo?
The null hypothesis.
Yes. Which hypothesis involves equality? The null again, right?
Mm-hmm.
Yeah.
The p-value is the probability of obtaining a specific statistic at least to the extreme of the one that was actually observed.
Null hypothesis.
When computing this probability, which hypothesis do you... Yeah, correct.
It's correct until it's proven wrong.
Yes. Okay. Suppose the null hypothesis is mu equals 10. Use the information. Which of the following represents the alternative hypothesis? It would be mu equals 10. I mean, doesn't equal 10.
Yeah.
The crossy thing?
The third one down.
Yeah.
It's scratched out.
Tail. That would be greater than?
Left-tailed test would be greater than, yes. Like mu is greater than 10, right?
And a right-tailed is nu is greater than 10.
Yeah.
Wait.
No, wait.
Hold on, wait a minute. No. The left-tailed test is
less than 10.
Is less than, right?
Yeah, and right-tailed should be greater than, because it's showing which way the tail of the V is supposed to go, right?
No. Yes. No? Yes. You know what I'm thinking is I'm thinking right skewed and left skewed.
I know.
Okay. Yeah. Sorry about that.
Okay. So what are we saying? That mu is, or so 10 is greater than mu.
No. For number 7, mu is less than 10.
Mm-hmm. And then for number
8, mu is greater than 10.
Okay, got it.
Oh my gosh, I had to get that skewed out of my brain.
Yep, I know.
Okay.
I love how these things are actually making sense again.
I'm struggling with this one.
Oh, I hate this stuff.
Yeah, I hate it.
I hate using Excel. If it has to do with Excel, I don't like it. But when it's just like, I don't know, for some reason this just makes sense to me.
Okay, well good. You can teach us, Abigail.
Oh boy. That's a lot of pressure. Okay. Determine by...
Okay, so I think it's number 1. P-value is greater than the null hypothesis. Because if P is low, reject the null, right? Did you guys get that?
Yeah. If P is null.
The P-value is less than?
So this says the p-value to the left. Okay, so yeah.
So it'd have to be the second one.
No, it has to be greater. Doesn't it have to be greater than the level of significance?
But yes. So the p-value is greater than the level of significance.
Alpha.
then we fail to reject the null.
Oh, that's right. This is alpha, not... I kept thinking it was a wonked up X. Okay, that's why.
Okay, so then which relationship would result in rejecting the null hypothesis is it has to be lower than alpha.
Yeah, so that would be the second one.
The second one. Okay. An insurance company is reviewing its current policy rates when originally setting the rates for the average.
That's a big claim.
But the true is actually higher than this. Oh, okay. Oh, I hate statistics.
Number related second answer for number 10. It's the first. Was that what you said?
I haven't said
sorry,
anything.
Susan.
So, appropriate alternative hypothesis would mean that the average claim amount is greater than. Because they're saying that they believe that it might be higher, which means that the alternate hypothesis instead of... So the null hypothesis is that the average claim amount is $1,500. But the alternative would have to mean that it's above $1,500.
The average claim amount is greater than $1,500. Is that what you said?
Yeah.
Sorry, I had to read it again. Is everybody okay with that?
Yes. Okay, but I'm sorry, forgive me on this, and I know this is really completely basic, but I get my greater thans and my less thans mixed up. So, okay.
It's totally fine.
Less than matches the left arrow, left.
Okay, here's my thing. Okay, I know we don't have to do this on this, but I'm just trying to understand it. If I'm going to write that out, I would write the mu, and then I would write the greater than sign towards the mu and the $1,500 on the pointy side. Is that right?
Yes.
Yes.
If it's greater than, that means that the first thing, so if the new, if it's greater than, that means that the arrow looks like Pac-Man is pointing towards new.
Okay. Just trying to make sure and keep this all straight in my head.
Okay, do you want to know how I remember it?
Yeah, how do you remember it?
Okay, so you have your mu over here, and then your greater than like this, so the alligator can eat it. But if it's like this, the alligator can't eat it, it's too small.
Okay, okay. Thank you. Thank you, thank you, thank you.
Grade.
Hey, well, whatever works. I just need something. I keep getting so confused on all it. I'm like, ah. Okay. Okay, so then which of the following would be the appropriate null hypothesis, and that would be the average claim amount is equal to 1,500. Correct?
The null, yeah, it has to be equal to, because that's the basic belief.
Yeah.
Okay.
Okay. 13 is the answer.
All right, so now we got to do our z-score thing, right?
Ah. It was going so well.
Okay, so yes, they do assume that it's normal because n is over 30, right?
Yep. Uh-huh.
Sorry, I'm going slow, you guys.
No, you're fine.
What theorem or law justifies your answer to the previous question? It is...
Law of large numbers, right?
No, central limit theorem.
Oh, that's right. I knew that. I knew that.
Because it's talking about... Okay, now wait a second. Because this... The sample size is large. The sample mean will approximately normally distribute. Okay, yeah, you're right. Sorry.
No, you're fine. I'm glad to double check.
And the law of large numbers.
I could have sworn, wasn't there a question on our assignment that said something about that?
No, we haven't talked about central limit theorem on any of our homework today for chapter 9.
Okay, then maybe it was some of the videos. Let me look real quick.
Oh, that could have been. I'm sure that's right because I have for my definition, if the sample size is large, the sample mean will be approximately normally distributed. So we're assuming that because n is over 30, that it's large.
Warren, wasn't there a question on our assignment that said something about that?
No, we haven't talked about central limit theorem on any of our homework today for chapter 9.
Okay, then maybe it was some of the videos.
You guys just went HD on me.
That could
I know.
Well, what happened there?
Right, because I have for my definition, if the
So
sample
does someone have two screens open?
the sample mean will be approximately normally distributed.
No.
So we're assuming that because n is over 30, that it's large.
Warren, wasn't there a question on our assignment?
Oh my goodness.
I got it. It was me. Sorry,
Okay.
I started watching our broadcast.
Oh.
All
Accidentally.
right, stop that, Abigail.
Sorry.
Okay, which of the following is the test statistics as defined in the lesson? That would be z-score.
Yes. Oh boy.
Okay, the historical mean. Okay, so now we have to figure this out.
Okay, just a minute. We'll have to get it later. Okay.
Increase. That's about 500. Okay, choose another. Okay. Okay, do you guys have your z-score?
I'm working on it. I got negative 0.9.
Yep. That's what I got. Everybody else? Anybody else?
Okay, so it says round to 3 decimal places. Just
0.900.
Hey. I'm like, okay.
Abigail and Susan, did you get that same thing?
Yes.
Now it's negative, right?
Yeah, that's what I got.
Okay. Yep. Negative 0.900, and the p-value is 0.184.
Oh, did you already open up an applet? I did not do that yet. Okay. What did you say you got your as for the p-scores, Lori?
0.184.
Okay, that's what I got.
Is that where we put the z-score?
No, that's
No.
the p-value.
That's the p-value. The z-score for 16 is negative 0.900. And the p-value associated with the z-score is 0.184. Susan and Abigail, do you guys know how to do all that?
I'm a little, like, I got it, but I'm a little, on it. So after this, I'm going to go and look it up again.
Okay, so we just did the regular z-score equation.
Yeah, the p-value is the only thing I have to go over.
Okay, so then the p-value, you take the z-score and put it in the probability applet, and because it's less than, it is, you fill in the left tail, the left farthest tail.
You shade the
Okay.
the left?
Yeah.
So it's like it's the same thing we were doing in the last session or whatever section. It's now, instead of just, we were always looking for the area. Now that area is going to be the p-value. So
does that look right?
Yep.
Yes. And does the top of it say 0.184?
Yes.
Okay, that is correct then.
Okay.
This is so much easier than the homework quiz. You're going to die.
Oh, really? Oh, great. That's not what I wanted to hear.
Okay, so then what inference would you make about the null hypothesis for this problem? Okay, now can I just ask you guys a question? Since that little ditty says, if P is low, reject the null. So P is greater than alpha, which is 0.05. So then we fail to reject the null. Is that right?
I think so. Let me look really quick here. I made a note on that. Okay. Yes, the p-value is greater than the whatever thing that is. So yes, we fail to reject the null hypothesis. Yes.
Okay. If we could just say true or false.
I know. That would be nice.
What's fail to reject mean?
Fail to reject means you accept the null hypothesis.
Okay, and see, that's the other problem I have with this stupid class is they put too many words in to say the simplest thing.
Why don't we just say we accept the null hypothesis?
Yes.
It's like I'm practicing legal jargon. I'm like, I'm not going to be a lawyer. I'm just going to be a social worker.
Okay, so, but it's fail to reject because 0.1841 is greater than 0.05.
Yes, I think so. I think that's what it would be.
Okay. Okay, now these type 1s and types 2.
I know. See, and that's the other thing. I'm like, why are we doing anything that might reject? If it's going to be cause an error, why are we doing it?
No, I don't.
Well, for type 1, if it's causing you to reject the null hypothesis when the null hypothesis is true, that's a type 1.
Okay, there are 2 types of errors that can be made when performing a hypothesis. Which one involves rejecting the null hypothesis when the hypothesis is true?
So it's a type 1.
Type 1. Yeah, that's what it looks like in that chart,
any other
right?
error, when it comes to a hypothesis test, has to be a type 2 unless it's talking about rejecting the null hypothesis when the null hypothesis is true.
Oh my word, Abigail, how do you understand all this?
Okay, now, Abigail, say that one more time really slow.
Okay. So when you're determining between type 1 and type 2, type 1, the only thing that the notes say about it is that a type 1 error is what will cause you to reject the null hypothesis when that null hypothesis is true. So type 2, by just standard removing all the other junk, since type 1 is rejecting the null when it's true, type 2 has to be every other error that has to do with making a hypothesis test.
Oh my word.
And I see that in my note too. When we reject the null hypothesis, and when the null is true. Okay, so I see that right there.
But don't get frustrated, Stephanie, because I get this part, but when it comes to using formulas, I'm at my wit's end.
Okay, well good. This one, I'm like, I already called Brian at work today and said, you're going to have to help me with this because I don't have a clue what's going on.
Oh my gosh, now this says, if alpha is 0.05, compute the probability of committing a type 1 error. Oh, well, it would be 5%. Right?
Okay. Yes, that on 21.
Yes.
Oh.
Yes.
What was 20?
Oh, sorry, we skipped 20.
Oh,
yeah.
So sorry.
I've been trying to pay attention.
Sorry. Are we sure? I was so excited to be done.
You are not alone.
The researcher decided that instead of using Okay, now I wrote this down in here.
Well, isn't that...
Okay, so this is what I have written down from the notes. To decrease the probability of making a type 2 error, we increase the sigma, or I mean the alpha. So to decrease the probability of making a type 2 error, we increase the alpha. Is that on there?
We're decreasing the alpha.
Okay, so to decrease the probability that it's a type 1 error, we decrease the level of significance. So we decreased it, so the probability of type 1 will decrease.
So then that would mean the probability of type 2 will increase, right?
Oh, see, that's not even an option, is it?
No, but remember, it's the opposite. They play the opposite. If the one decreases, then the other increases.
Wait, so you're saying the probability of type 2 will increase?
Yeah.
Yeah, that's one of them. It's the second one.
That's right?
I think so. I'm looking in my notes. Hold on.
Well, on page 18 it says we do not want to commit type 1 errors. So why not choose a very small value for whatever that is, A? So we choose A to be so small that we rarely commit a type 1 error.
Right.
Okay,
so
I wrote down in my notes that it says probability of creating a type 1 error. When one goes down, the other goes up. So if the probability of creating a type 1 error goes down, then the probability of the type 2 error will go up.
Okay.
Does that make sense?
Yeah, because that's what it says here on 8.
On 8.
Where are you, Susan?
Yeah.
Page 8 in the text.
Oh, you have the text. Oh, I just have that on the computer.
I always have to print them out.
Can you print them out?
Yeah, I go to the library and do it.
Okay. I didn't know you could do that. Okay, well, so
I have to read on the internet.
I'll just have to take your word for that because I'm lost. Okay, so then if alpha is 0.05, compute the probability of committing a type 1 error. Is that just 5%?
Yeah, that's just because.
So the probability would just be 0.05?
Because I wrote on my thing that the alpha level is the probability of making a type 1 error. So whatever that probability is, that's the type 1 error, right?
Yep, I see. Okay, I've got that too in mind. Yep.
So do we put 0.05 or do we put 5%? Probably 0.05, right?
Well, I put 0.05 because normally when they do percent, they add that percent for you.
Oh, right, right.
So 0.050 or just 0.05?
I just put 0.05.
Okay. So 20 is the probability that a type 2 error will increase, and 21
I think
is
so.
Okay.
Okay, was there anything else we needed to go over?
Not that I remember.
Okay, wait a minute. I do want to go over these stupid little alligator things again.
Okay.
Okay. All right. I didn't answer number 9. I don't know how I missed that, but okay.
Do you want to go down all the answers quick so we haven't missed anything?
Yeah, let's do that.
Okay, so question 3 is the null hypothesis, number 1. Question 4 is number 1. Question 5 is number 1.
Yeah.
Question 6 is number 3.
Yes.
Question 7 is number 1.
Okay.
Question 8 is number 2. Question 9 is number 1.
Number 1. Okay.
Question 10 is number 2.
Okay.
Question 11 is number 3. Question 12 is number 1.
Yeah.
Question 13 is number 1.
Yes.
14 is 2. 15 is 2.
Yes.
16 is negative 0.900.
Yep.
17.184.
Yep.
18 is 2. 19 is 1. 20 is 2. And 21 is 0.05.
Yep. Okay.
Now the only thing so do you want to go over those again? Because I'm okay to go over stuff.
No, that's fine. I'm confused on the alligator things again, but I'm gonna have to work on that obviously. So
okay, can we just go over 3 through 5 again?
Yeah.
A hypothesis test consists of the null hypothesis. Which one? Okay, so status quo is the null.
Uh-huh.
And the equality one is the null.
Yeah.
And then p-values of the probability of retaining this. Yeah, okay.
Okay.
We just kind of went through those fast.
Right.
And then the two-tailed is not equal to, the left-tailed is less than, the right-tailed is greater than.
Okay, see here, this is where I get confused. Okay, so number 7, we're saying 10 is, okay, so it has the mu and then the alligator facing the 10. So that means the mu is less than 10?
Yeah.
I'm reading that right?
Yeah.
Okay.
Or if you can only remember the greater part, then read it backwards.
Okay.
10 is greater than the mu.
Greater than mu. Okay. All right. Okay.
So are we ready?
Yeah, I think so.
All right, let's go for it.
If we missed any on these, 100%.
Oh, good.
Woohoo!
Yay!
Okay.
All right, guys, good. So the homework quiz is pretty brutal, huh, Lori?
Well, it's not brutal, but it's not as easy as this was.
Okay,
For
I'll have to
sure.
do lots of studying then.
No, you get to take it twice.
But it's
I
not.
always go in and take it right after I do my preparation at homework.
Oh, yeah. Uh-huh.
And then if I have to take it again, I
Study for it. Okay. Hey, that's a smart idea because I stress about it and I study, and then I still always end up taking it twice anyway. So.
Oh my gosh, just take it right after you do your preparation assignment and your homework assignment.
Okay, that's a good idea. I'll do that.
All right.
All right, thanks,
I'm out of
guys.
here.
Thank you.
All right,
Bye.
Tuesday. Bye.